Are you curious about the science behind sound? Do you want to know what sound is and how it works? Well, look no further. In this video, we'll be diving into the world of sound, exploring what it is and how it works. We'll explain the science behind sound in an easy-to-understand way so that everyone can learn something new. Introduction to sound and vibration. Sound is created by vibrations and is transmitted as a pressure wave. Vibrations occur when an object or source moves to and fro, causing nearby air molecules to vibrate in the same pattern. This chain reaction of particles bumping into one another continues until the sound waves reach their destination. Humans perceive sound as the result of these pressure waves interacting with our ears. These sound waves are detected by our ears and converted into nerve signals, which are then interpreted by our brains. The frequency and amplitude of the sound waves determine the pitch and intensity of the sound we hear. How is sound transmitted? Sound is transmitted through a variety of mediums, including solids, liquids, and gases. When an object vibrates, it creates kinetic energy that is transmitted by molecules in the medium. As the vibrating sound wave comes into contact with these molecules, they vibrate in response, transmitting the sound wave in all directions. This is known as wave propagation. The speed of sound depends on the density of the medium it is traveling through and can be affected by temperature fluctuations. In air, sound moves at a rate of 343 meters per second, which is much faster than in water or solids. The scientific community refers to sound as acoustic waves due to its ability to travel through air pressure changes. Our ears are able to detect these sound waves and transform them into nerve impulses that are sent to our brains, where they can be interpreted. The science of sound and human hearing. The science of sound and human hearing is complex. To understand it, one must consider the physics of sound and its interaction with the ear. Sound waves travel through the air and cause vibrations in the eardrum. These vibrations are amplified and sent to the inner ear, where they are detected by hair cells. These hair cells detect changes in air pressure, transforming them into electrical signals that the brain interprets as sound. The pitch or frequency of a sound is determined by the number of waves per second that pass through a medium. Humans can hear frequencies between 20 Hz to 20,000 Hz. Noise is any acoustic phenomenon that causes an unpleasant or disturbing sensation. This includes high-intensity sounds that can damage hearing over time. Data sonification is a way to translate data into sound, allowing people to better understand information presented in a different format. As this blog post has demonstrated, sound is a complex phenomenon and requires an understanding of both physics and human hearing to truly comprehend it. Sound waves and their impact on the ear. We have seen how sound is produced and transmitted, but what about the impact sound waves have on the ear? When sound waves enter the ear canal, they cause the eardrum to vibrate. This vibration is then transmitted to three tiny bones in the middle ear known as the ossicles, which amplify and transmit the sound to the inner ear. Here, tiny hair cells line up along the cochlea and respond to specific frequencies. These hair cells send sound waves to the brain so that we can hear. When these hair cells become damaged or are otherwise unable to send proper signals, hearing loss can occur. Additionally, loud sounds can cause permanent hearing damage if we are not careful. Data sonification, translating data into sound. Data sonification is the process of converting data or information into sounds that exploit the auditory perceptual abilities of human beings, such that patterns, Trends and correlations present in the data can be quickly identified. It has powerful applications in research, education, and outreach, allowing for a more inclusive approach to science communication. By translating data into sound, sonification can reach audiences such as the visually impaired, who may not be able to access visualizations. Sound ecology represents the sounds in the environment that can be heard, while data sonification extracts sounds that are hidden in scientific data and which would otherwise be inaccessible. Shelzel is one of many musicians and researchers working in data sonification, a field focused on translating data into sound. In the current fascination with sonification, the fact that aesthetic decisions must be made in order to translate data into the auditory domain must not be overlooked. The physics of sound. Sound is a type of energy created by vibrations. When an object vibrates, it causes the surrounding air molecules to vibrate and move in a wave-like pattern. This movement is what is known as a sound wave and is the basis of all sound production. Sound waves consist of vibrating particles that travel through air, water, and other materials. As the particles vibrate, they collide with other particles, creating a ripple effect that carries the sound away from the source. The speed of sound waves varies depending on the material they are traveling through, with air being the fastest medium. The intensity of the vibration also affects how loud or soft the sound will be. Scientists have studied the physics of sound for centuries and have developed numerous methods for measuring and analyzing sound waves. The interaction of sound waves in different mediums. The interaction of sound waves in different mediums is an important factor in understanding the nature of sound. Sound waves can travel through solids, liquids, and gases, but each medium affects the sound differently.